Welcome to Brain Vision.
Okay, so this problem is asking us to find the internal forces at J for a bow, assuming that the target, the archer is pulling with a 45-pound force. So the first thing we would want to do is find the forces in the two strings. So if that's the archer pulling back on it, then there's two strings, and you can imagine that that's what the bow is. So this is 45. This is, let's say, T1. This is T2. The first thing to realize is that by symmetry, T1 and T2 will be the same. And then the next thing is that we can use the measurements given to construct a 3, 4, 5 triangle. And therefore, since the forces are balanced, we can say that 2 times 3/5 times T minus 45 equals 0, because nothing is moving, everything's balanced. The 2 comes from the fact that there's 2 strings, and the 3/5 comes from the triangle, so we know that T1, which equals T2, is 37.5. Okay, so now we move on to finding, we also know that the bow is parabolic, so we can say that it's given by the equation x equals ay squared, basic equation of a parabolic function. So if we move down and we draw the force diagram for this, going all the way from C to B, with the midpoint J right here, you can imagine that the bow curves something like that, but this is going to be simplified in the way that it's represented, because we know that this is 16 inches, and we also know that this distance right here, from here to here, is 8 inches. Then we also have this measurement alpha for the bow. We know that if we're going to end up making a cut at J, so there's going to be some force there, a V there, and some moment. This 45-pound, this force is coming from, the string being pulled, and once again, we have the equation of the parabola given, and now we can also set up the 3, 4, 5 triangle that we have here, similarly to how we have the tension when we're doing that equilibrium, and now we can solve. So the first thing to realize is that if we take point B, we can say that x equals 8 inches at that point, and y equals 32 inches. So if we plug it into our equation to solve for A, we get that A equals 8 over 32 squared, which equals 1 over 128. And further simplified, we know that x equals y squared over 128. We can also find the slope of the parabola by saying that the tangent of theta equals dx over dy, so the change in x over the change in y. So x is going to change by 2y, and we know that dy is 128. So we get that tan of theta equals y over 64. Now, since we have the overall slope, we can use that to find what we need at point J. So for theta J is going to be the inverse tangent. If you remember, J was 16 inches up, so it's 16 over 64, which is 1/4. That equals 14 degrees approximately. And so that means that if we want to solve for this value alpha, alpha is going to be inverse tangent of that 4-3 triangle minus the 14 degrees that we just got, and that will give you about 39 degrees. And so now what we're going to do is find the forces that are perpendicular and parallel. So that'll be parallel will be along the axis y prime, and perpendicular will be along the axis x prime. So if we do equilibrium, and that force about x prime, excuse me, let's erase that. X prime, we're going to have f, if you want to solve for, plus 37.5, which is the rope pulling on it, and that's going to be acting at an angle of the sine of 39 degrees, which we just found. So you should get that f equals negative 23.647, and we also have to find the direction of it. So if go back here for f, again you would this theta j value, and so which means you can find if this is 90 degrees, you know theta j, subtract from theta j, and then you can use trigonometric relations to find that it acts at an angle of 76 degrees. Excuse me, it's 14 degrees. Oh, sorry. F, I did the math wrong in my calculator. F is, oh no, I did that right, I'm sorry. F is minus 23.7 and acting at an angle of 76 degrees. Sorry about that. If we do F in the x prime direction, we know that equals 0. So it's very similar to what we just did. So we're just using cosine. And so we know that V equals 29.1 pounds, acting at an angle of 14. Again, using those trig relations that we know. And then last but not least is the moment about J, which equals 0. So there's going to be the moment itself. There's going to be the moment that is 16 inches away that is caused by 3/5 of 37.5 from the force triangle and the tension of the string. Then we will add, it's going to be 8 inches minus the 2 inches that go from J to C. So you will get 8 minus 2, which is 6 inches, times 4/5 times 37.5. And so if you solve for all that, you get that the moment equals 540 pound inches clockwise.